percent thing because I had some stuff to take care of last week.
I was confused, but it was no matter because I didn't have anything at 3:30. Though I do have a 4, so I'm going to have to make sure I get out of here by 4. All right, let's get on to circles. We've the two most important equations for circles are area equals what?
Pi r squared.
And circumference equals what?
R squared. Or R.
2 pi. Remember, it's the same three numbers, but bring the 2 down in front. 2 pi
okay,
r.
2 pi r.
Uh-huh.
Yeah, 2 pi r.
Okay. Between those two formulas, if they give you the radius, you can figure out area and circumference. If they give you the area, you can figure out radius and circumference. Or if they give you the circumference, you can figure out radius and area. So you just need one of the 3 pieces of information to answer all questions about circles. So they give us the area and they ask for the circumference. Let me put a little room in between these two, just as a hint. So they're giving us this is 64 pi. What does that allow us to solve for?
Radius and circumference.
So what's the radius?
Eight.
And now what is the circumference?
16.
16 pi.
Yeah.
Okay. I'll leave these up here for just a bit because we're going to use them probably in every single question on this part of the exam or part of the quiz. If each of these is at the center of their respective circles and the radiuses are 2, 3, 4 respectively, what's the perimeter of this triangle? There's the triangle. I'm going to draw it. There's A, B, C. What is the length of AB?
AB would be 5.
What is the length of BC?
7.
And AC?
6.
Perimeter?
18.
All right. Let's talk about circles for a minute. Let me go down here. The total distance around the circle is 360 degrees. Okay? In other words, if I put a grid on that, it's 90 degrees to get from here to there, another 90 to get from there, so it's 180 for a semicircle. It's 360 around the whole thing. Now, if I said, what's the length of this arc between that point and that point, it would be 90 degrees.
Mm-hmm.
And you can see that that represents 1/4 of the circumference. So this angle would have to be, if that was 90-degree arc, this angle would have to be 90 degrees also, because the arc represents 1/4 of the circumference, and so this angle has to represent 1/4 of the 360. Okay, this problem, they're saying something similar, only it's not 90 degrees, it's the point. This distance from there to there, that curved distance, is in a ratio of 1:8 with the circumference. Hold on, let me make sure I read that right. The ratio of the circumference of circle B to the length of arc ADC, which is this tiny arc, is 8:1. So let's figure out what this angle is. What kind of a ratio can I set up?
I don't know.
Well, we could say that 1 is to 8. This little arc segment is to the entire circumference in a 1:8 ratio, is the same thing as x, the angle, is to 360 degrees. So now if we solve for x, we get 45 degrees, I believe. Yeah. So x equals 45 degrees.
Okay.
Now, let's talk about that a little bit further. The same thing applies if I wanted the ratio of the area. This thing is called a sector. When you break up a circle like this, from the center to the circumference, you have a sector. Okay? Well, the area of that sector is in the same relationship as the area of the angles. In other words, if they told me what the area of the sector was, I could also figure out the area of the whole circle. In the similar manner as I figured out what the circumference of the whole circle was. Everything's proportional here. Mm-hmm. All right. No, excuse me. I was trying to read this to fit it to this picture, and I realized it doesn't fit. All right. Excuse me. All right. Now this is a relatively difficult question. Let's first of all figure out the area of both of these circles, or semicircles. What's the area of this circle right here? Excuse me, what is the area of that semicircle?
Semicircle?
The area of the small semicircle has a diameter of 4. So what's its radius? Radius is always half the diameter.
Mm-hmm.
So the radius of this semicircle is 2. So the area, if I had a full circle, would be 4 pi. Since I only have half a circle, that area is 2 pi. Okay? What's the area of the big semicircle?
A to C6. The area, so 4.5 pi.
Good. Now, shaded region problems. are always what kind of problems?
Subtraction.
Yes. So what is this shaded region going to be?
2.5.
Uh-huh. The area of the big semicircle minus the area of the small semicircle.
Mm-hmm.
And that answer is... hold on. I didn't read the question very good. Yeah. They didn't want the area of the shaded region. They wanted the fraction of the larger semicircle does the shaded area represent. Well, the shaded area was 2.5 pi. And since they want a fraction, we're going to put that all over the area of the larger semicircle, which was 4.5 pi. And that fraction, if I double the top and double the bottom, I get 5 to 9. So it's this answer. What is that question doing in the basic? That should be at least an intermediate, maybe hard. All right, next page. Hold on. It's always a good idea to draw pictures. All right, so to draw this picture from the first sentence, let's start with the circle. And they're saying that a line segment joining 2 points on the circumference, well, let's put 2 points like that, and there's the line segment joining them, is 1 inch from the center of the circle at its closest point. Therefore, that is 1. Okay?
Mm-hmm.
That's what that first sentence translates to. If the circle has a 2-inch radius, what is the length of the line? Well, the other key thing about circles is that all radiuses are the same. If I draw that line right there, that is a radius. I could also have connected this point to that line. That's also a radius. There is a theorem in geometry that says that if you take this line segment and connect it to the center, it makes a right angle. In other words, that is a right angle, and it also bisects this line. So now all I have to do is solve this triangle, this right triangle, whose dimensions are 1, 2, what's this one?
3? Or,
Remember, your answer always starts out square root of.
square root of, okay.
So it's got to be square root. Remember, they've given us the hypotenuse, so it's the square root of the hypotenuse squared minus the other side squared. So yeah, that's square root of 3.
Okay.
So what's the length of that line? In other words, what is the square root of 3 is this right there. So what'd you say, 2?
Yeah, 2 times the square root of 3.
Yeah, because that line is bisected. So
yeah.
The whole line is twice that distance. It's a pretty common problem right there in geometry. That's pretty classic. Okay. Let's start with the algebra. Which of these can you solve for? We are given AB. Can we immediately solve for CD?
No, you can immediately solve for BC though.
And what is BC going to be?
8.
Now we
So
can solve for CD.
CD equals 16.
Okay. So the area of the entire shaded figure.
28 pi.
I don't think so. Let's see. Let's take this first.
Oh, the area. Oh, sorry, I forgot. Okay.
What's the area of the small circle? Remember, these are the diameters that they're giving us
That would be 8 area for the small.
here. Hold on. It's the radius is 2. It's pi r squared, so it's 4 pi divided by 2, not multiplied by 2. So that area is going to be 2 pi. That's the little one. Let's do BC next. What's that radius?
4.
What's the area?
6 or 8.
8 pi. Don't forget the pi. In other words, we don't convert that pi to a number. But the downside of that is forgetting to write it sometimes. And finally, CD, the big circle.
The area would be 32
Pi.
pi.
Add them all three together and you get 42 pi. Figure above, okay. All of these are always the figure above. All right. So let's start with the information they give us. The area of the circle is 100 pi. What does that allow us to calculate?
The radius
Is what?
10.
Okay. So now I can draw my triangle here. And I know that's 10. In other words, OB is the same distance as OC. All radiuses within the same circle are the same. So that's 10. And they're saying CA, which is this little segment here, is 6. Well, they want AB, that segment right there. But first of all, we got to calculate this segment right there, AO. What is AO going to be?
6.
What kind of triangle? That's a right triangle.
It would be 8.
Okay, so that's 8. What's AB got to be?
2.
You're picking up on this stuff pretty good. I don't know how much of this stuff is familiar to you or totally new.
Totally new for me.
You're picking up on it good. If you can get through proofs, you'll do just fine in geometry. Proofs is only the first month, and it's only confusing because it's strange. And I can certainly help you get through proofs. And in fact, we can take a look at some proofs before you start back to school, which is when?
The 18th.
Okay. So we got at least another session. Okay. Okay, and the figure above. if the area of that triangle is 25, what does that allow us to calculate?
Allows us to calculate the radius, wouldn't it?
Well, they've given us the area of the triangle. In other words, we're looking at a triangle, but it's not just any triangle.
It's a right
It's a right isosceles triangle. This side here is the same as that side there, because all radiuses are the same.
Okay, so wouldn't it be 10 base times height divided by 2 would be 25, since 10 by 10, or, well, that's what I'm thinking.
Well, let's hold on. Let's solve this.
Okay.
Let's call this distance x. So it's 1/2 x squared pi.
Okay.
1/2 pi r squared. Excuse me. It's 1/2 base times height, but if this is x, so is that. So it's actually 1/2 x squared. And they're saying that that is equal to 25. So solve for x. Once you have x, you'll know the area of the circle.
All right.
What's the first step in solving this equation?
Square root both sides.
Let's isolate the x squared first.
Okay, so
We don't want to take the square root of the right side, because then we got to deal with taking the square root of 1/2.
multiply both sides by 2.
Okay, so that leaves us here.
Okay.
And if you prefer, I can make that r. Now, r is clearly the square root of 50, right?
Mm-hmm.
Now, normally you would have to simplify that. You wouldn't want to give an answer as square root of 50 because that's not simplified. That should be 5 root 2. But in this particular case, since they're asking for the area of a circle, and the area of a circle is pi r squared, we don't really need to solve for r. We just need to solve for r squared, which we did in the previous step.
Okay.
So what's the area of the circle?
I don't know.
Well, plug it in up here. This is the area of the circle. It's equal to pi, and r squared was 50. 50 pi.
Okay.
Okay. In other words, I could have solved for r and let it be square root of 50, or even simplified that to 5 root 2, and then plug that in for r up here. But you see why I didn't actually have to need to solve for r? At no point did they ask me what r was. They wanted the area of the circle, and that really is a function of r squared. If I know r squared, I'm done. I don't have to go all the way down and get r. Now let's see what the advanced look like. There's two ways to do this problem. The easiest is probably to set yourself up an example. What's the area of that circle?
4 pi.
What's the radius going to be of this circle if it's 50% greater?
3.
And what is the area of this circle?
9 pi.
So by what percent will the area of the circle increase? Well, it more than doubled, right?
Mm-hmm.
It actually went up by 5 pi. Well, 5 pi relative to 4 pi is an increase of 125%. And
Okay.
notice that this gets a little tricky. If you say that something is 50% greater, then it goes from 2 to 3. At the same time, I would say that 3 is 150% of 2. You see why that is so? And why it's a little confusing.
Mm-hmm.
Okay. Just always make sure you're translating the English right. In other words, we know it says it increases by 50%. If the diameter does, so does the radius. And that's why I set up the first radius to be 2 instead of 1. If I'd have made that 1, then I'd had to make that 1.5, and so forth. But in the end, by what percent will the area of the circle increase? Well, it increased by 5 pi. Well, if you said the circle increased by 100%, it would go up to 8 pi. Excuse me one moment. Hello? Hello? Yeah, I'm not interested. Thank you. Bye-bye. Sorry about that. I thought that might be my next student. Let's see if we can maybe take a look at one more question here. So we got a lighthouse, and it emits a light that can be seen in all directions 60 miles away. What's the radius of that circle?
30.
Actually, it's 60.
60. Okay.
See why? Because
Yeah.
if you're here, you're 60 miles away, you can still see the lighthouse. If you're over here, you're 60 miles away, you can still see the lighthouse.
Okay.
Approximately how many square miles is the region of visibility increased if you increase it by 40 miles in all directions? In other words, I got another circle over here that's 100 miles. Let's make this one 100 and let's make this one 60 since I don't have any room. Okay, so this is the first circle, A. This is the new circle, B. By how many square miles have we increased it? And they want an absolute number, not a relationship here. So what's the area of this one over here?
60 squared. Let me pull out my calculator real quick.
You don't need your calculator. What's 6 squared?
360.
Well, it's 36, and then you need 2 zeros to handle the square.
Okay.
So it's 3,600 pi. That's the area of the smaller circle. What's the area of the larger circle?
1,000. 10,000.
What's the difference?
6,400
Pi.
pi.
And notice, you got to be a little careful. They'll do this on the ACT test to you also. They give you an answer that's close to that. But there's no way, and they even say approximately. But notice they didn't put pi with any of these answers. So 6,400 pi is approximately 20,000. In other words, this is one of the cases, where they want you to convert it to a decimal.
Okay.
And they would trip up a lot of people here. And they weren't obvious enough to actually put 6,400. If they'd have put 6,400 here, most everybody would probably miss this problem.
Yeah.
But by putting 6,300, it's just enough off because it's not approximate. It's exactly 6,400 pi.
Yeah.
Right? So there's no way they would ever approximate 6,400 as 6,300. So that gives you a chance to take second pause and realize, I got to multiply that thing by 3.14.
Mm-hmm.
All right, we'll stop there. Pick up next week.
All right, sounds
All right,
good.
Cole. Talk to you next week. Bye-bye.
Bye.